In this video, let's look at how to create another table and link the first table that we created on customer with another table. This is where we're going to build what we call referential integrity through foreign key. There are different types of referential integrity, and we can actually look at how each one works. This is probably one of the most important concepts of database. Once you understand that, you understand how to create a database with multiple tables and how to create the connection between one table to another table using what we call foreign key. Once you understand this, this will help you in actually doing queries. So let's go ahead and create another table. In this particular table, we're going to capture the account information of each customer. We'll make an assumption that an account has exactly one customer, but the customer can have any number of accounts, what we call one-to-many relationships. Let's go ahead and create another table. So let's call that, we can rename it, and okay, so it's still open, so we cannot recreate it, but let's go ahead and go to view, design view, and call it example1 account. Say okay. So in this case, I want to have account like the previous time, account number. You can define this account number to be a character or a number. So let's look at as a text itself so that we can say it has, say, 9 characters. I'm not going to look at input mask here. You can check some validation rules you can put if you want. So account number, account balance. By default, account balance has to be a number. The number can take fractional values. So if you look at number and field size integer, it can take long integer, which means it's a very large number, or a small number, or it can take what you call double, which means it can take any number of decimal places. Okay, and we always say the default, the validation rule means it has to be greater than 0 because the value, the account balance cannot go negative. We'll say always greater than 0. Validation text or greater than equal to 0. Validation text, let's say enter a number greater than 0 or greater than or equal to 0, account balance. Then we'll say account holder. Now who owns this account? If you recollect, this account holder is the same as the customer social security number from the other table. I want to link them. So certain basic rules. The account holder was a social security number. We defined that to be of size 11, and we defined the input mask to be, say, yes, social security number. It has to exactly match the same data type in the other table. You can give a different field name, that's perfectly fine. But what you need to exactly match is the data type. If you use a different data type, it won't match. So it'll give you an error when you try to combine them. Say next, say finish. So it has the input mask. So this data type is exactly the same as the data type in the table example1 customer. Now, in this particular table, the account number is your primary key here. So if you go back, right click or say primary key. So we know that account holder is the one that references the other tables to verify this customer exists. Now the question is, we need to define that relationship, but we don't do it here, we do it with another method. So you click here, exit, say yes. So we have now 2 tables, example1 account, example1 customer. So we want to build a relationship between these two. Go to database tools and you see relationships. You might have 1 table or 5 tables or 100 tables. All the tables in some way must be connected. If there is one table that is not connected to anything else, often you're going to see there is an error. Not often, it will be most of the time there's an error there. Unless a table exactly has 1 row. So let's now go ahead and build relationships. So you click on that, it'll ask you, hey, add these two. They're different. We can double click, you can select all and say add. So we know this customer SSN is connected to this account holder. Take a few seconds to read, edit relationship. Customer SSN from the example, from the table example one customer is related to the account holder in example one account. Now, how do you know which one does it take? We always know this is a primary key of this table. When you drag and drop it this way from this table to this table or from this table to this table, any way you can drag it, always the relationship comes out like this. Why? The primary key of this particular table can be linked in the other table. We can enforce referential integrity. So once I click enforce, what does it mean? You can never enter anything in the table example one account unless that particular account exists in this particular table customer. Let's go ahead and create. Keep in mind we have cascade update, cascade delete. We'll look at how that works. And the relationship type is one to many. What does that mean? For every one customer here, remember that customer SSN cannot change. It cannot repeat. There can be only one. For every one of this customer, you can have any number of accounts. But the account can only have one owner, account holder, because there can only be one entry of account number. Just say create. The database engine could not lock because it's already in use by another person or process. Say okay, that's fine. What is happening here is this particular table exists here, so when that is open, it won't let you create the lock. Very often, you'll see many of them keep these things open and it refuses to create those relationships. Get it out. Go back and try that again and enforce. Okay. If you go back and say join type, it'll tell you only include rows where the joined fields from both tables are equal. Include all records from existing one customer and only those records from existing example one accounting where the joint fields are equal. Read that. This will come in handy when we do querying. In this case, let's look at only the rows here can appear in this particular table, and we're going to enforce it. Say create. So we now build a relationship that says 1 to infinity. For every one customer SSN, there can be any entries in this particular table account. It can be 0, it can be any number, even 10. So let's get it out. Say yes. So let's go ahead and test this particular table account 1. Remember, this account 1, account number can be anything. So let's say 2, 3, 4, 5. Since it's a character, you can even put AB. So we have 1, 2, 3, 4, 5, 6, 7. So we have 9. Let's say account balance is 750.9 and account holder. The account holder has to be matched exactly the one that is there in this particular table customer. Let's put some arbitrary one. 111, 11, 11. Hit enter. Since this particular account holder doesn't exist in this existing customer, let's see what happens. You cannot add or change a record because a related record is required in a table example 1 customer. So since 111, this account holder does not exist in the account customer, you cannot enter that. Say okay. Go back and enter the one we actually put earlier, that was 1, 2, 3, 4, 3, 2, 2, 2, 2. If you recollect, Ashish had a social security number of 123432222. Hit enter, it accepts it. So you want to go back and see the customer. You see Ashish is there with the same social security number. Let's go and enter another one. I'll just put some arbitrary number. Let's say minus 98. It says you cannot put 98. It cannot be negative. It has to be greater than 0. Say OK. So let's see the poor faculty with no account balance. That's me. So let's go and say 1, 2, 3, 4, 3, 3, 4, 5, 5, which is mine. If you hit enter, you see it accepts it. So any entry in this particular table account, the account holder must already exist in the customer table. If it doesn't, it won't let you add that. So that's what we talk about maintaining the referential integrity. So let's go ahead to that relationship that you have. And what I'll do is I'll go double click on this link. I'll say cascade update. Say OK. So what does that mean? Let's see here. You have the account number, customer access number. So account already has an account number with this particular social security number. So now if I change this particular parent, the child is automatically cascaded. Updated is cascaded. So if I go back and say 11111, so I'm going to change the social security number of Ashish, hit enter. Let's go back and see what happens to the account table. You see the account holder 123432222 now has changed to 111, which we have updated, which means we are cascading the update from the parent to the child. That's what the relationship allows you to do it. If you try to change it, so assume this is 111, let's exit out. Go back to relationship, go back here and say cascade, remove this cascade update, but use cascade delete. Say OK. Go back to the customer account here. Now I'm trying to change this 111. Let's go back and make it 222 for Ashish. Since I didn't check that cascade update, if I try to hit enter, it won't allow you to do that because there is a child record in the account table. Since we have not checked that cascade update, what it does is, hey, if there's a child already, then you cannot change the parent. But if you check that cascade update, then it allows you to do it. If you don't check it, it says you cannot change the parent if the child exists. If the child was not there, then you can change it. No problems. But if there is a child, then you cannot update it. So let's go back to 1111, which is now, so just say escape. So you see account table here, it has 111, we are fine. Now you remember we checked cascade delete. What happens if I delete this customer Konana? So just hit delete. Since we have specified the cascade delete, so it's going to delete one of the rows in the other table where you had this relationship, which is in the account table. Say yes. So if you go back and look at this account table, my account does not exist anymore. That's how cascade delete works. You have to be very careful in using cascade delete because once you delete it, it's gone. You can't recover it. Okay. So that's the way you use the referential integrity with different constraints, cascade update, cascade delete, or either not using either one of them.